Hello everyone, welcome to my presentation on interactive hydrodynamic water modeling within an enterprise GIS. My name is Jonas van Schoonsen Landman and when I started first with GIS over 15 years ago during my studies and I learned about this big conference in San Diego in the United States, I always thought I should really try to be there one day. Well, after 15 years I finally managed to be here at the 2020 Esri User Conference, albeit not in person, but digital. So when you look at the title of my presentation, the term hydrodynamic water modeling might not be familiar to all of you. So let me explain that a little bit. In a GIS, you can calculate the direction that the water might be flowing. You can see the digital elevation model and how the water might be going down. But the complex process of how the water from rainfall is going to spread in volumes and in velocities over time, that is a highly complex numerical modeling for which you need expert systems. And we're not only going to do that, we're going to use that, but we're also going to do that in an interactive way. So let me start by introducing a few worldwide trends that are affecting the water sector. First of all, climate change. We see an increase of precipitation, also more scattered precipitation. You can have heavy rainfall in one part of the city and being dry in another part of the city. Also, you see an increase in droughts, floodings, the sea level rise, which is increasing. All this together leads to new water management challenges worldwide and especially in the Netherlands. Another trend that we are seeing is that more and more decisions are being made driven by data. In the past, a water manager used to look at the weather forecast and try to predict what that would do to his or her water system. Nowadays, we have a weather forecast. We can combine that with the outside world. We can calculate how the water is flowing, and based on those results, we can make decisions impacting the water system. So instead of having some gut feeling like, okay, this amount of rainfall, we need to do this and this and this, we can make this a data-driven decision. So if we then combine these trends and look at the future of water management, together with Esri the Netherlands and the Water Authority of North Holland, we have looked at what does this mean? What does it look like for us? And for the Water Authority of North Holland, we came to the following ambition that we would like to have a 24/7 insight in the status of a water system on any square meter. So for the past, the present, and the future. Of course, we have already some insight as what is happening in the system. We know that from sensor data what is happening on that exact location. But when we don't have sensor data, we don't know what is happening. To be able to do so, you need to make like a model of this outside world and use this sensor data combined together to get an insight of your whole water system. This insight for the whole water system, for the past, the present, and the near future, with everything combined, is something that does not exist yet. So, to have a bit of insight of what we're talking about, let's have a look at the Water Authority of North Holland. For those of you that don't know it, it's part of the Netherlands, at roughly the same area as the province of North Holland. And it consists of a lot of polders. Almost the whole area contains of polders. On the west side we have the sea, on the north we have the sea, on the east we have a large inner lake, and the lowest level of this area is around -6 mean sea level. To get all these polders dry, to get the water to the sea, we have over 20,000 kilometers of waterways. To put it into perspective, the River Nile or the River Amazon, they're roughly like 7,000 kilometers in length. Of course, the waterways in these polders are not as big as these rivers, but just to give you an idea of what length we're talking about. Also, to get the water out, there are 24/7 pumps pumping the water out. There are 364 controlled pumping stations and over 4,000 controlled weirs in the water system. And of course, if you keep water out, you also need dikes. There's over 380 kilometers of dikes, 84 kilometers of sandy shores, and over 1,000 kilometers of small dikes in the system itself. So these are impressive numbers for such a relatively small area. So if we combine these trends, our ambition to have a 24/7 insight in the water systems, there are a few challenges we are facing. First of all, we are looking at the complex processes involved. Of course, in GIS nowadays, you have more and more insight, you have more and more information of the outside world. You know where the buildings are, you know where the cities are, you know where the channels are located. You might even know the width of the channels. You might know the exact locations of the levees, the dikes. But these are all representing the outside world in a digital twin, so to say. First we have digital twin, of course, in the 2D, just on the map. And lately you see more and more detailed digital twins in 3D. Some are even so detailed that they are exact representatives of the outside world. That if you show it to a citizen living in a certain street and you see this on the screen, it's like, yeah, this is an exact image of my street. And what you need is, this is the basis that you can use, but you need to involve the complex processes if you want to have a 24/7 insight in a water system. The first one is the weather. You need a weather forecast. You're not going to calculate the weather forecast within a GIS, but you can use the weather forecast, the results of the weather forecast, and use them in calculations or visualize them. The same goes for the water system. You can have a lot of information on the water system, but how the water is actually flowing. So for example, if you have a precipitation event, a rainfall event, and the water is flowing through your system, through your pipes, through your canals, how is it actually moving? That is a complex process to grasp, and you need expert systems for that. Also, another complex process is the humans. They also have an impact on the system. You can open or close controlled structures. You can have an impact on how the water system interacts. That's also something that you need to grasp. Another challenge that we have is the amount of data. The amount of data is only increasing. It's not going to become less, but only more and more. An example of that, if we look at the digital twins, that they are more and more detailed, from 2D to 3D to actual textures on buildings, well, you can imagine that means also quite an increase in the amount of data. And also the resolution of this data. If we look at the digital elevation models in the Netherlands, they used to be 100 by 100 meter. Nowadays, we are calculating by 50 by 50 centimeters. And worldwide, this is a trend. The digital elevation models are becoming more and more accurate. So if we look at the Dutch example, if we go from 100 by 100 meter to 50 by 50 centimeters, that means that you have 40,000 more data points for that one pixel that used to be 100 by 100 meter. So that's also quite an increase in the resolution and in the amount of data that you're using. And people expect you to interact with that data. They're not satisfied to hear, oh, we have this super detailed elevation model, but sorry, we can't really use that. That's too much detail. That's not what people want to hear. That's not what people expect. Another thing, another challenge is the understanding of time. The understanding of time has changed over the years. In the past, when you ordered something from a post-order catalog, it could take weeks before it was delivered to your house, and that was fine. Nowadays, you order online on Amazon.com and you expect it to be delivered the next day or even the same day. And if we look at the water management, the weather forecast, for example, there's not just one weather forecast predicting the rainfall event. No, you can have like a worst case scenario where there's really heavy rainfall, and a best case scenario where there is less rainfall, obviously. And then something in between. You want to see the effect of those events all at the same time. So you have multiple timelines that you have to follow. So with these trends in mind, with these challenges that we are facing, let's have a look at our approach towards a 24/7 insight in the water system. Well, what you need to have this insight is first and foremost a location to bring it all together. The expert systems, they are in place, but you need to connect them all together and make them available in an understandable way using dashboarding. Here's where the ArcGIS platform comes in. I'm not going to be able to explain the whole slide, but this is quite a familiar slide for the Esri community. The most important thing for us here is that ArcGIS can use APIs to connect to other software. You don't need to understand what exactly an API is. It's simply a way for software to connect to other software, and that's it. And this makes the solution in the ArcGIS platform flexible. By using APIs, you're interoperable and integrable with other solutions. So if we look at our complex processes that we need to grasp, we will not grasp these processes by calculating, for example, the flow of water within a GIS. We're using an expert system for that and connect with that expert system using an API. That means that we have some demands that these models need to fulfill to be able to use them. So in this case, if we want a 24/7 insight, we need an open API. We need full control of that model. We don't want to simply start a calculation and wait an hour, for example, and then analyze the result. No, we want to start the calculation, have full control over that calculation, because if something happens, something changes in the weather forecast and we need to change something, how the model interacts, we need to be able to change that. And to be able to do that, you need to have insight in what is being calculated at the real time. So for that you need streaming possibilities. And also, well, obviously you cannot really do all this on your own laptop. You need scalable computing power. And in this case, we do that in the cloud using services. So in this example, we use 3DI, a hydrodynamic modeling software matching the demands. In this project, we are at the first step. We have taken the first hurdles. And one of the first things that we need to be able to do is to be able to interact with the modeling software. So in this example, what I'm going to do is I'm going to start a flood simulation from within an enterprise GIS. In this case, ArcGIS Pro. And I'm going to connect to this to the 3DI computational server, and I'm going to start a calculation. I'm doing that by using a toolbox with Python code to build the API call, so to say. The user does see barely anything of that. Thanks to the ArcGIS Pro, we can just make a simple interface that's fairly easy to build up. We choose a model that is available online. We choose, in this case, in this example, this is just a simple example of what you can do with an API. Is we choose the duration of the simulation, amount of rain, and the duration of the rain time. And in this case, we are to show the interaction, we are simply asking the progress. But it does not stop there. I will show that in a few slides. It does not stop there. So we see here the progress of the simulation. We are downloading the results, some log files, and that's it. The results are being downloaded, and then when we plot them in ArcGIS Pro, they look like this. So here we have the water depth on the surface. We have the canals, we have the lines, and for a modeler, this might be a good way to actually analyze the model results. But to show it to people that are not experts in hydrodynamic modeling, it is a bit more complex to understand. But when we use the ArcGIS platform, we have more ways to visualize our results using a portal or ArcGIS Online. In this case, we use the 3D view to show how the flood actually is in the water system here. So we see here the outcome of a flood simulation, the 3D buildings that are available, and like this you can color them. In this example, they are colored on the function of the building, but you can also color them on the depth of the water. You can do analysis with what stories are maybe still dry. So can people run up to a higher story, or do they need to get out and evacuate? All these kind of analysis become available. And of course, I was talking about the streaming. So let me give you an example of that. So for this 24/7 insight, you need to have fast and quick results. You need to have streaming results. So here, let's say we have a calamity event, but this could also be a precipitation event where there is a certain amount of rainfall coming on the water, on the system. And we follow here on this location, we follow the water. And we can see the water level increasing. We can see the water depth increasing. And in this case, we can see that the water depth, we can quickly see that it is after 4 hours, slightly over 20 centimeters. So not really life-threatening yet, but it's a lot of water, and you don't really want to have this, but you can you can't even swim in it. This is to show you an example of how streaming works. We are looking live at the outcomes of the 3DI calculation core as the results are being calculated. So in conclusion, in this project where we are at the beginning, we are in a 3-year project where after 3 years the Water Authority will have a 24/7 insights on any square meter of the area of the Water Authority. To be able to do that, we have achieved real-time water modeling in GIS. We already have seen some examples of that. And of course, we will be generating terabytes and terabytes of water data, which can be used for data science purposes to make better decisions on what is happening in the water system and what we can do. That concludes my presentation. Would you like to follow our project? These are the parties involved: Esri Netherlands, the Water Authority of North Holland, and the company of Nederland & Schuurmans. Here you see my email. Don't hesitate to contact me. You can also connect or follow me on LinkedIn or check our movies on YouTube. Thank you for your attention. Please share your feedback in the app.